My name is Zach Roland. I'm the project manager for this GDP, Remotely Deployed and Recovered UAV. For this project, the team has developed two separate aircraft, one in collaboration with Arizona State University for the American Institute of Aeronautics and Astronautics Design Build Fly competition, and the other, Toto, we have developed to demonstrate autonomy for our sponsor, Thales.
My name is Hirat Gadazi, and I'm the flight system engineer for this project. For this aircraft, we use multiple sensors to achieve autonomy, using a motion sensor, using an airspeed sensor, and a GPS to provide us with accurate position of the aircraft during the flight. Using these sensors, the aircraft is capable of performing an autonomous flight based on a number of waypoints provided by the user.
The two briefs for this project have introduced some really interesting design challenges. So at the conceptual design stage, that's meant developing a highly parametric CAD model. It's also meant linking that to a MATLAB code that can optimize the CAD model for structural and aerodynamic design, and with which we can use to run a trade study of hundreds of different designs to best optimize the aircraft.
A Monte Carlo analysis enabled us to generate a probability distribution of the center of gravity, which are then linked to the mass model.
At the manufacturing stage, we've developed our own in-house vacuum forming and foam cutting methods. Working with the ASU Air Devils has been a really exciting component of this project. Through this partnership, we've been able to combine our experience in Southampton with UAV design, with the Air Devils' significant experience competing in DBF competitions.
I'm Philip Thomas. I'm the president of Air Devils. Air Devils is a student organization at ASU where students learn how to design and build RC aircraft for competition. The aircraft must carry a series of bouncy balls to represent passengers, and it also has to carry blocks to represent cargo. When Dr. Takahashi, which is our advisor here at Air Devils, he came up to me saying that we have an opportunity to work with the University of Southampton. I jumped on it immediately because many of us have had yet to really take a real aerodynamics class or a real aircraft performance class, and so we were hoping that having this collaboration with the University of Southampton would benefit us heavily.
Having combined the expertise of both teams to produce a high-performing aircraft, we were able to place second overall in terms of mission score for the DBF competition. The performance in the competition in Kansas has helped to validate the same design philosophy we used here to manufacture Toto. So today we've had our second successful flight test of the Toto aircraft. We've flight tested the 360-degree camera, and we validated some structural and aerodynamic changes to the tail design, which has improved the flight stability of the aircraft. Despite experiencing one engine failure during flight, we were still able to successfully land the aircraft. The next stage of this project is to conduct a fully autonomous flight test.